Hello, my dear students, and welcome back. So today we'll move to section 8.4. We're still working with the chapter 8 about infinite series. We're done with 8.1, 8.2, 8.3, and today we'll be covering a short section, this one like one of the shortest section about alternating series. Now we need to understand this type of series. What do I mean by alternating series? So the plan for this section is just only we're going to learn this type of series, the alternating series, and we'll learn the test that we can use to check convergence or divergence of the alternating series. After that, we're going to learn just how to find estimation for the summation of alternating series. Now, firstly, anything just we start with alternating, so that means it's changing the sign between positive, negative. And the part of the series that control this, that control the alternating part, is this one, negative 1 to the power. Sometimes it's k plus 1, anything the power. It's negative 1 to the power of k plus 1, where k starts from 1. So if you try 1, then the first term should be positive, then negative, positive, negative. So it keep alternating, okay? You need always to check you start with what? Just by applying the first one. Here we assume that AK and all of the terms of the sequence are positive terms, okay? So the sequence itself is positive term. What make it alternating is this part. Now, if we think about one famous example here, this is what we call the alternating harmonic series. Remember 1 over k, we took it already as a harmonic series. Now, what about if it's alternating harmonic series? Does it make any changes? Remember, for the harmonic series alone, for the harmonic series, which we covered before, we know that sigma for 1 over k from k equals to 1 to infinity is divergent. This is, we already know that from the previous section. Now, as a harmonic series, it's divergent. What if we add alternating part to this sequence? What will happen? Okay, this is what we need to check first. This is the graph of this alternating harmonic series. So it looks maybe it's going to go somewhere around 0.7, as you see. Okay, so maybe it's going somewhere around 0.7. Now, we need to learn how to check that. Is there any test we can use for any alternating series? Yes, there's a specific test for alternating series, which is this one. Now, what does this test say? What we call the alternating series test. It says that if the limit of AK equals to 0, this is basically like the kth test, right? This is basically the kth test. So if the limit of AK equals to 0, and the AK is greater than or equals AK plus 1 greater than 0. This means that this is decreasing sequence. So this is the first condition. This is basically the kth test. So if I use the kth test, it's equals to 0. That means I need one additional condition. I need this condition. This condition means that this is decreasing sequence. Decreasing sequence. I remember we checked decreasing before by checking AK plus 1 over AK. We need to say that this is less than or equals to 1. Okay, this is the easiest way to check if the sequence is decreasing or not. So AK plus 1 over AK less than or equals to 1 for all k greater than or equals to 1. If these two conditions satisfied, so I can say that the alternating series converges. Okay, so what do I need to check? I have to check two things. One, that the limit equals to 0. Two, that it's a decreasing sequence. The limit equals to 0 and it's a decreasing sequence. If the limit does not equal to 0 directly, this is the kth test, it's divergent. No need to continue up by checking if it's increasing or decreasing or whatever. So we stop. If it does not equal to 0, it's done, divergent. If it's equal to 0, then I need to check the other condition, okay? Now we need to do that for the alternating harmonic series and see, is it converges or not? This is the alternating harmonic series. I need to decide what's AK in this case. AK for this question, you take it without the negative 1 to the power of k plus 1. So AK is basically 1 over k. Now the first condition that I need to check, I need to check the limit for AK as k approaches to infinity. And this is equals to limit of 1 over k as k approaches to infinity. And this is clearly equals to 0. Okay, so the first condition is satisfied. It's equals to 0. Now I need to check the second condition. The second condition, I need to know if it's increasing or decreasing. Remember, anytime you need to check increasing, decreasing, you have to prepare AK and prepare what's AK plus 1. So this is 1 over k plus 1. Okay, now I'll divide them by each other. So AK plus 1 divided by AK, this is equals 1 over k plus 1 times the reciprocal for AK, which is k over 1. And this is equals k over k plus 1. Now see, we know that k is basically starting from where? 1 and above. So k is greater than or equals to 1. So it's positive and greater than 1. So if you compare between the numerator and denominator, just look at both of them. Clearly, both of them, they have kk, but the numerator is smaller. It has 1 less. So clearly, the numerator is smaller. So by this is like proper fraction. So this is less than 1. This is less than 1. So that means it's decreasing. It's a decreasing sequence. Now this is the second condition. So now what do I have? The limit equals to 0. And I have it as decreasing sequence. So those two conditions, once they are satisfied, I can say that hence sigma, the question itself, negative 1 to the power of k plus 1 over k from k equals to 1 to infinity converges by the alternating series test. Okay? Remember again, anytime you use any test, you need to justify your answer. You need to write which test did you use. So now this is an interesting fact. I need you always to remember this one. So the harmonic series alone, it's divergent. When it's alternating, it's converges, okay? This is an important fact we'll use later on. Let's see what do we have next. Let's try another question. This one. Again, we need to do the same thing. We need to investigate the convergence or divergence for this alternating series. Remember, this test works only with alternating series. If you don't see this part of negative 1 to a power k or k plus 1, this is not alternating. So this test works only with alternating series. Okay, now what's AK in this case? It's k plus 1 over k times k plus 1. Remember, I need to prepare AK plus 1. So this is equal. You need to change each k with k plus 1. K plus 1 plus 3, this is k plus 4. This is k, now it's k plus 1. Plus 1, now it's k plus 1 plus 1 plus 2. Okay? Now I have to check the first condition. The first condition. I need to check first that the limit for AK as k approaches to infinity equals to what? So this is the limit of k over plus, this is k squared plus k, right? If I expand, this is k squared plus 1. And if you check this limit, direct substitution, it will give you infinity over infinity, right? If you do direct substitution. So remember the rule, we multiply by 1 over k to the highest power in the denominator. What's the highest power down? It's squared. Times 1 over k squared. Okay? So now this is equals to what? This is equals, in the numerator I have 1 over k plus 1 over k squared Down I have 1 plus 1 over k as k approaches to infinity. Clearly, the numerator will be approaches to 0, down it will be 1, so this is equals to 0. So now the first condition is satisfied. I know you can get this quickly just by looking at the ak, because the degree of the denominator is bigger. So I know it tends to go to 0. But remember, we can't use L'Hopital directly. So either you use x or you divide, always multiply by 1 over k to the highest power in the denominator, just to show the system. But for you as a self-check directly, if you see the degree of the denominator, you know it's 0. Now the second step, or the second condition, I need to check whether it's decreasing or not. So I'll start with ak plus 1 divided by ak. And this is equals ak plus 1, it's k plus 4 over k plus 1 times k plus 2 times the reciprocal of ak. Remember, every time what I'm doing is k plus 1 times 1 over ak, just to avoid complex fractions. So now the reciprocal for ak is k times k plus 1 over, this is k plus 3, right? This is k plus 3. The original one was k plus 3, so what does it change? This is only 3. Yeah, that's all. Okay, so now this is k times k plus 1 over k plus 3. Now see if there's any cancellation before you multiply. It's always recommended to cancel out before you multiply. So there's k plus 1 with k plus 1 will be cancelled out. Okay, great. And then let's multiply and see what do we get. And this is equal, what do I have in the numerator? K times k plus 4, which is k squared plus 4k. Down, I have k plus 3 times k plus 2, which is k squared plus 2k, 3k, 5k, plus 6. Clearly, if you compare, this is k squared, they are the same. 4k smaller than 5k. 0 here, there's nothing. 0 less than 6, so this is clearly less than 1. So this is decreasing. So it's decreasing. So this is the second condition satisfied. So if I have the two conditions satisfied, I can easily say that hence the series converges by, I'll call it from now on the alternating series test, okay, by the alternating series test. And we're done. You see, very simple two conditions. Let's see what do we have next, if we have one additional question, okay? One more. It's again alternating series, and I need to check if it's converges or diverges. Okay, I'll prepare. So what's AK in this K? In this case, it's K over K plus 2. Great. Now I'll try to find the first condition. Check the first condition. The limit of AK as K approaches to infinity, it's equals to limit of K over, this is K over K plus 2 as K approaches to infinity. Direct substitution, it's infinity over infinity. So either you use L'Hopital rule or you do what? You multiply by 1 over K and down by 1 over K. And this equals to limit of, here it's 1, down I have 1 plus 2 over K. K approaches to infinity. You do the limit, this is equals to 1, which does not equal to 0. Remember, the condition we need it to be equals to 0. If it does not equal to 0, so this is, in this case, it failed the Kth test. So I can say directly, hence, the series diverges by the Kth test, or the divergent test, by the Kth test. You see here, I didn't mention the alternating series test. because always the first condition, if the series failed the first condition, this is basically the kth test. Okay, again, from the beginning, you can check yourself that it's equals to 1, it's clear, but you need to show that. Okay, so clearly, if you look at the degree, they are the same, so you know that it will be equals to 1. But we need just to add one additional step to show that. Okay, hopefully all is clear so far. It's an easy test, easy to check. Okay, see what do we need, what do we have next? This is the solution for the same question. Now the only part left out of this section is just how to find the error, just exactly as we did with the integral test. So there's sometimes that we need just to check the error. Why do we do that? Why do we do the estimation? Because again, with this test, you can say that it's converges, but to what? We don't know. Okay, so I can guarantee it's converges, but I can't find to what value. So the idea here is to find the error or the estimation for this summation. It's just exactly as we did before. I need to find the summation only up to n terms. Okay, up to n terms. So the error will be the absolute value of s minus Sn. Always it should be less than it's always the absolute value of the first neglected term. So I add up to n. What's the first term after? It's an plus 1. So think about it this way. So you're adding the terms from a1, a2, you're adding all of them, you're adding them. Okay, this is a series. Plus you reach an, then you continue. So I add only from a1 to an. What do I lose? Any error always should be less than an plus 1. The next neglected term, the one that we didn't add. So it's very easy, simple. Okay, how can we find this error? You need to know that this error should be under one condition, that this is already converges using the alternating series test. So basically, as a previous step, you need to check if it's converges using the alternating series test. If it's converges, then you can do the estimation, or else if it's divergence, there's no estimation. You can't even find the summation. Okay, remember always as a prerequisite to check or to find the approximation or the error, the series should be converges, or else it means nothing to find the error or the estimation for the total, for the summation. Something like this. It's exactly the same way of the integral test. The question will come in two ways. The first one, we need to approximate the sum of the alternating series by 40th partial sum. So they add up only 40 terms. So n equals to 40. They add 40 terms. And estimate the error of this approximation. And we need to find the error. We need to find the error. This is what we need to calculate. We need to find the error. Okay? Now, what does the rule say about the error? We know that S minus S40, S minus S40 should be less than or equals A41. Again, I write the rule here. So it's S minus Sn less than or equals An plus 1. But before that, okay, we need to check that this is converges by the alternating series test. So I'll leave it as an exercise for you. You need to show that the series is converges by the alternating series test. Okay, we need to show that this is already convergence in order to find the approximation. Okay, it's easy task. You can easily check that. Now, we need to find the error. So now we need S minus S40 should be less than or equals A41. Okay, what's A k in this case? It's 1 over k to the power 4. It's like P series. Okay, A41, this is equals to what? 1 over 41 to the power of 4. 1 over 41 to the power of 4, okay? And this is approximately, if you use your calculator, this is approximately 3.54 times 10 to the power of negative 7. So we can easily say that the approximation, okay, it should be like plus minus 3.54 times 10 minus 10 to the power of negative 7. Okay, so this is what it's off by. Okay, what should be our value as if we add it up to 140? Just you can easily find this by your calculator. Any calculator can find the summation of up to 40 only. From k equals to 1 for negative 1 to the power of k plus 1 over k to the power of 4. So this is our estimation. This is what do we need to find. And this value will be approximately, if you use your calculator, this is about 0.940326439. So this approximation is just almost the same like the addition or the summation up to infinity. The only difference is just only plus minus this value, which is small value. Now the next style of questions, this one is directly, you just say less than A41, the next or the first neglected term, and that's it. The next type of questions, they give you the error, the estimation that you need it to be within which value, the range, and then you need to find how many terms to add. Something like this. So for the convergent alternating series, so they told you already it's convergent, okay? So we have it already from the previous question, it's convergent alternating series. How many terms are needed to guarantee Sn is within 1 times 10 to the power of negative 10 of the actual sum S? So here they told us what's the error. The error should be less than or equals 1 times 10 to the power of negative 10. And we need to find n equals to what? How many terms do we need to add? So basically what you need to do is this. So I know the error is S minus Sn. It should be less than or equals An plus 1, okay? Now, what's An plus 1? This is equals 1 over, okay, 1 over n plus 1 to the power of 4. Remember, this is AK. 1 over k to the power of 4. I need An plus 1. You just replace k with n plus 1. So this is the value. I need this to be less than or equals 1 times 10 to the power of negative 10. So basically what you need to do, you need to solve this inequality only. I need to solve this inequality just to find approximation for n. Okay, easy, we can do it. So let's solve this inequality. Now I have this 1 over n plus 1 to the power n plus 1 to the power of 4. For sure this is positive, okay? It can't be 0. This is greater than or equals to 0, less than or equals. This is 1 times 10 to the power of negative 10. If I take the reciprocal, or I write it just with positive power, so this is 1 over 10 to the power of 10. Remember, we did this last time. If I take the reciprocal for this whole inequality, so now I have n plus 1 to the power of 4. You need to switch the inequality sign. Greater than 10 to the power of 10. Okay, again, I remind you. So this is a less than or equals to b. Both of them, if they are positive, greater than 0. So if I take the reciprocal, 1 over a should be greater than 1 over b, and they are still greater than 0. So once I take the reciprocal, I need to flip the inequality sign. Okay, this rule works if they have the same sign, either both positive or both negative, by the way. But they should have the same sign in order to do this. You switch the inequality with the reciprocal. Okay, now this is easy. Remember your target. You need to find n. So you have to solve this inequality for n. Take the fourth root to cancel out the power 4. So n plus 1 equals the fourth root of 10 to the power of 10. Now still I need n minus 1. So n equals fourth root of 10 to the power of 10 minus 1. Notice that minus 1 outside the square, the fourth root. And this, if you use your calculator, okay, you can get this as approximately 315.2. 315.2. Okay, so how many terms do I need to add to get this approximation? Remember, n is an integer, so we don't accept decimals. So I need always to take the next, don't do rounding. Okay, it's not you do round down as a 315. Always when I think about integers, I take the next integer. So 315.2, what's the next integer? 316. Okay, so it's not rounding. We take the next integer. So n equals to 316. That means I need minimum, okay, minimum to add 316 terms to get this accuracy. 316 terms, it's a lot. Okay. Hopefully all of this is clear. That's it about the alternating series test. Okay. We need just only remember the test. You check two conditions. Limit of a k equals to 0. Check if it's decreasing, just as we did with 8.1. And you need to know how to find the error. And usually the questions about the error, they have like two styles. Either you need to find how many terms to get this accuracy, or you need to, they give you n, how many terms to add, and you need to find what's the error should be less than what. Okay, that's it for today. Take care.